Good morning everybody, we are back for another tropical cyclone update, and today we're going to be going through Tropical Cyclone Garance, which is a significant threat to Réunion at this time, the French Overseas Department of La Réunion. As we can see, the Météo France forecast, the latest one issued 6 hours ago. Maybe we'll get one during this video, a new one, but at the moment with the one that we have, they have a intense, I should say, they've got a tropical cyclone at the time of issuance of the advisory, and at the time they ended up forecasting a intense tropical cyclone peak heading right into a almost direct landfall into La Réunion, and obviously that's not particularly good. That, if comparing to the Saphir-Simpson hurricane wind scale, that is a major hurricane coming into La Réunion, so that would be a pretty significant event. This hasn't happened much before, so this would be quite a rare sight to see. And obviously we got Tropical Cyclone Honda there as well, getting through and towards southern Madagascar, but that'll be in another video potentially, either later today or tomorrow, or maybe never, I don't know, whenever my schedule allows. At the moment we'll focus on Garance as we look at the threats to Réunion. So, what do Météo France currently have for La Réunion? Well, let's take a look first. They've got an orange cyclone alert at this time. This will likely become a red alert later today and tomorrow at the time of landfall. It will be probably at a purple alert. Again, this doesn't happen much. This is a direct major hurricane landfall heading for La Réunion, so it absolutely would not surprise me if we get a purple alert coming up. And already on at seas, they've already got, for waves and oceanic conditions, they've already got absolute vigilance on the periphery on the northern side. So if you do live in La Réunion, obviously I am not an official source of information, I would like to note that. Please follow Météo France and any of your local authorities to make sure that there is precautions in place to make sure that your property and your life is safe. There is an orange cyclone alert, so any precautions that need to be followed under an orange cyclone alert, make sure you follow that and keep up to date for any future alerts issued by Météo France. Now this is the current radar that we have. I will reload the page for the latest. I think it already was reloaded, but actually no, I don't know. There you go. Right, let's play it. I'll speed up the animation. There you go. So, this is local time. Just so you're aware, La Réunion is 4 hours ahead of Zulu. So, currently the latest frame would be at, let's take a look, it will be at 6:10 Zulu. We're 4 hours behind this, just so you're aware at the time I'm recording this. What we currently have here is a very solid core structure from since when it entered radar range, and the strongest reflectivities are on the south side. Now I'm going to slow this down because I do want to analyze this a little bit more deeply. As we can see there, the strongest reflectivities all the way through are always on the south side. Always on the south side there, strongest reflectivities. And why is this? Well, we'll take a look at an infrared animated satellite images soon, but it will be pretty clear why. What it appears to be a pretty formidable core structure for most of the way around, like we can see there. Like they've got very nice core structure there, very evident eye there. It's quite solid, but there is shear happening around, and where it's becoming evident that, yeah, there is a lopsided structure for sure, because to that point, to this extent, supposedly vortical hot towers at whatever reflectivity level is being scanned here, we can see that there is a struggling to rotate around the northern quadrants. It's struggling to wrap up shear. And what I mean by that is that there is shear coming in from a west-southwesterly, or or should I even say just southwesterly, really. From a southwesterly direction, I'll go more into that. There's a southwesterly shear, essentially westerly for like I really, and that is preventing any upshear rotation of any vortical hot towers, at least at this level. Obviously, on infrared satellite images, that'll look a bit different, but from what we can see, reflectivities are unable to wrap that way because there is some westerly, southwesterly shear that is impinging onto the system, and it's only going to get worse. But at the moment, we're seeing some likely intensification. This shear isn't completely destructive. It's obviously having an effect on the strengthening and the organisation of the system. But from what we can see, there is some shear. The reflectivity values are lopsided and are not covering all of the core. Now, this is the infrared satellite imagery I want to talk about, so let's obviously so you guys can see the timer. It's early morning hours. We can see very effective wrapping. I'm not going to deny there is very good wrapping of vortical hot towers. That's certainly a truth. And we can see a pretty nice, formidable central dense overcast with a nice, formidable eye. That is actually clearing as we speak. And one thing to note, though, is that, again, there is lopsiding. Though it's more evident when we look at the outer bands here, because I should probably change my colour. It's evident as we look at the outer bands because we can see there's a lot of banding here, lots of banding there, and there's very little there. Very little banding here. I should probably highlight that a different colour as well, just so that's evident. We'll look at white instead. Very little banding there, and even outflow cirrus as we look there, like outflow cirrus that will try look expand from there, it struggles because that most of the deep layer wind vector is southwesterly, and that is impinging onto the system. Although the ability to rotate vortical hot towers is pretty good, it is still happening. It is still quite effective. Though, as we can see, there's definitely shear impinging onto the system. There's evident shear. There's a lot more convective activity free to roam around here compared to this side of the system. But overall, organisation of the system is going pretty good. Let's take a look at the eye temperature. We're sticking at about near positive here. It used to be high, or should I say, it used to be deep negatives. And recently, as we look into today, it's briefly cleared into positives. It's fluctuating between mid-20s negatives into near positives. So it's looking pretty good right now, and it is obviously trying to stabilise. With the shear, it's going to become a little bit increasingly difficult, but at the moment we can see that eye is there. There is a central dense overcast of some sort there. It's certainly not the worst. I've seen worse in terms of structure, and it does mean that we've probably got a strong system here. Right, this is Dvorak BD imagery, and this gives us a little bit clearer of an insight on how the structure of the central dense overcast and the eye is. We've got very cold cloud tops, continuously wrapping. Those are vortical hot towers, and obviously that's trying to stabilise, trying to constantly wrap. It's a fairly small central dense overcast. We can see it's not particularly wide. It's actually not a particularly big system. This had fairly isolated monsoon origins. When I mean isolated, I mean typically on the western end of the monsoon trough, forced by interaction with Madagascar's coastline. This is roughly where Genesis took place. And generally winds along that monsoon trough on the western portion, it all forced to tighten up circulation along the eastern coast of Madagascar. And that's why it wasn't so broad. It didn't have to tighten up itself. It actually got some support from a nearby landmass, and therefore it managed to intensify into a fairly compact tropical cyclone. But nonetheless, we can see fairly small central dense overcast, but it is trying to wrap. Very effective wrapping as we looked. Quite violent wrapping. We can see wrapping there, vortical hot towers. Keep wrapping. Though it is still yet to stabilise fully the central dense overcast. Plus the eye is fluctuating, but it's back at this time as I speak. It's not too bad at the moment. And this is currently what we have associated with the system at this time, or as of 3Z, so we'll probably get a new analysis in the next few hours, but we'll take a look here. This is the upper level wind analysis going from 100 to 500 millibars, and we can see very well, outflow is definitely trying to come out from here, and some limited outflow can extend onto there, but there is generally a northerly vector that comes onto there, and oh yeah, we do see some flow going that way, but there's some northerly flow impinging. This is upper level, so nothing too much of note in terms of shear affecting the system really. But yeah, it's there, just thought I'd note. But otherwise we've got outflow going this way, so that's effective, although not particularly too strong, but there is some upper level outflow going through, and it's pretty widespread. Now this is where the strongest outflow goes, southwards, polewards, fairly good. This is not too bad of an outflow environment, but though evidently seen, this is Hyundai, if you can see there on the bottom left corner, this is Hyundai, and it's got a much better up-level environment. We've got a very nice, broad anticyclonic regime. Now, why am I talking about Hyundai here? Well, because Garance is here, and Hyundai's here, we see all this environment, this up-level anticyclone aloft that Hyundai has. It impinges on Garance. This is where the southwesterly, kind of flow comes. Really, this is where it comes. It's where it comes from. Sorry, broad up level anticyclone. It's impinging onto that system that we got Garance here, and therefore we obviously have a bit of a stagnation in the reflectivity wrapping. Right, so as we've gone over the current kind of situation, what's going on with Garance and the warnings earlier on and the official forecast by Météo France, now let's actually dive in to the model guidance and what we can observe ourselves. What observations can I make? And I'm going to go through and talk through some of the things that are happening in terms of the model environment and synoptic environment that will lead to where it goes. Let's get right into it. So, basically, this is the GEFS ensemble, and we can see all its various tracks. This is initialized at Series Z, so fairly recent. This is the most recent run that we have here. And what we can see here is that initialized at 959, this is close to best track evaluation, so fairly good. I'll look into why this is important in a second. I'll show you guys. And we do have landfall expected 24 hours from the initialization points. This is around 18 hours from now. A landfall in La Reunion, almost direct. It lasted about 24 hours or so, 18. And then, as we go into 48, track spread gradually, naturally increases. Obviously, that's not too unusual. It's definitely normal that this does happen. There is obviously growing uncertainty through time. And then 72, going out to 96. Although it narrows a little bit, not really. There is still quite a big spatial area of 72 points. Although it's more, I guess, it's broader, but it's a bit more of a bit less circular, it's a bit more elongated of an area of 72s, nonetheless a very broad area. So spatially large area, but not really extending that way. Uncertainty does remain though. This is mainly timing that an upper deep layer trough does pass through and pick up the system as a main steering influence. And then obviously, yeah, everything just goes very loose from here. Hour 120, 44. Very big range there. That's extending around 10 degrees. Although generally chunk of the guidance extends. We're probably looking at about 5 degrees of an extent when it comes to uncertainty at time at the end of the forecast period. That's hour 120. And let's observe any trends that we got here. We can see stronger, so we look at the colour mark here based on hectopascal pressure, minimal mean sea level pressure of the system, and we can see the stronger members track on the eastern side. Why is this? Well, there's probably, obviously as it heads south, there is probably some a trough ridge pattern influence where a trough is picking up a system, having some influence of the system, trying to take it poleward. It's already probably, by any passing trough, it's probably like a trough here, it's probably already having some influence on that trough, a little bit more than the members more so on the western side. And those on the eastern side, stronger members will be tracking more under the influence of a trough. That is how it is. You will have stronger systems and then stronger influences, stronger interactions, and therefore that's why we have some stronger members going on the eastern flank of the guidance. And the same continues really for gear, and hence why it's a little bit above the consensus down the line. Though we do also have an unusual member gear, which I'm not sure what exactly happens here, but he does a bit of a loop there, and then re-strengthens, and then heads down there. That is an anomaly for you, and that's not really something to take into account. But this is more of a trend that we can analyse there, because it's more than one member that actually follows this kind of evolution. Now, this is the European ensemble here that we have, the EPS. And what there is to know is that there is a more of an influence to take the Western solutions. There's many more Western solutions there. Quite a few. I believe what it even looks to be the majority that doesn't actually take it over La Reunion. La Reunion just being that island there. And although quite a lot of members nonetheless definitely do take it through La Reunion, many don't, and they take a bit of a kind of a track to the west. And what probability is set out by whatever algorithm they have to calculate probabilities at this website, easterlywith.com. They have the capital city of La Reunion, St. Denis, the main municipality, having an 80% probability of a strike of some sort, which is not great. But it's most important to take a bit of a trend between most of the guidance, all the different types of guidances that we have, and this is the ECMWF. This is not the GFS anymore. And notably, quite a bit of contrast in this situation, and this can happen everywhere. You know, if there's land in the way, you definitely want to look closely on where there's going to be a strike and where there passes, because there'll be a drastic change of impacts between the two solutions. And here we'd have the brunt of the eastern eyewall to begin with, if it does take a more western solution. So you will have some winds prolonging, but the most impactful downfall will be a direct strike, which is what the GFS and some of the other models suggest. While this appears to be an outlier, we'll take a look if it is an outlier for sure, but it definitely looks starkly different to some of the other guidances that I actually looked at before this video, and to the GFS that we just looked at. Nonetheless, let's take a look at some of the intensities. We got pretty strong intensities. We've even got one member going down to 933, another to 934 in terms of pressure, but the deterministic takes it down to 960. The control takes it down to 960. The general average from a glance looks to be around 960, maybe 955 as the minimum central pressure for peak out of these members. Now let's do a bit of a comparison actually. So we have a bit of a recurving motion as that trough probably picks up at this latitude. We're looking just above 35 degrees, 35 degrees here. Model agrees, generally some agreement on that, though what I think I see is a bit of, let's see, we've got a bit more of a curved direction, while we have a more, I guess, sudden turn. So it's a bit more sudden of a turn on GFS. I feel like what we need to take into account here, I thought I'd mention, is that what we'll have is, what we've noticed over the years from my personal observations is that the ECMWF has a bit of a bias towards less influenced by any passing trough, or a bit of a bias towards having stronger ridging than actually observed, than actually compared to other models, and then ends up underperforming relative to the model. Yeah, it does forecast ridging to be a bit too strong at times, and the troughing to be too weak. And this happens with tropical cyclones themselves as areas of low pressure. Typically on the ECMWF, they tend to be a bit weak either at initialization and in the forecast most of the time subsequently. And that's why we've probably got a bit of a track more to the west. I'll be looking more towards the direct stroke to La Reunion, and I'll go into that when we go into intensity a little bit more, because this will be involving intensity. But basically, to begin at the moment, we've got a ridging over there to take it southwards. And this is stronger than the GFS, and then a trough passing by will have lower influence, more gradual influence, as this storm obviously will try to engage. I'm sorry, I'm kind of getting a bit annoyed at this time right now because I've got a fly on me, and it's distracting me quite a bit while I'm recording this. Now let's take a look more into the steering and kind of what we have here on a plot here, looking at geopotential height 500 millibar steering. So as I said, yeah, we got this nice. I need to put the pen on. We got nice bridging over here that will steer it south alongside, obviously troughing there that actually allows it to take the route further south, and allows the ridging to be in this configuration. And we can see it takes that dive south for 24 hours, just after 6C, makes that pass through La Reunion tomorrow, heads south, and it becomes less evident. Now, this is probably the increasing shear that I was on about earlier, that ends up weakening the vortex and weakens it to the point where it does not have as much of a vertical extent. You can see some element of some resemblance of a trough there, have a low pressure that's there, and that goes under that ridge and follows the trough, tries to get there, but it doesn't actually make it. Again, it's similar to the situation that we had with Saru, where there is influence by a passing trough. It gets steered by it, but then it obviously misses it, and eventually it'll get to the point where ridging fills back in after it and will not be able to follow it, and therefore it gets stuck in the subtropics and ends up decaying in a bit of an environment that is not suitable. One thing to do best is to also look at the ensemble and see what kind of spread we have. Although we've looked at the ensemble track spread already, we can visualize it here a little bit better, and we can even look at 850 to actually see what the vortex is on a much better level, and to see the spread even as well. Obviously, yeah, there's good spread going for La Reunion. I mean, it's supposed to be happening tomorrow, the landfall, so obviously no surprise there. There will be decent confidence this far out, though that confidence fairly quickly does begin to extend a bit further out. Actually has a little bit more confidence than Hyundai has over there. As we can see, higher vorticity, so that's probably higher density of members, while density of members isn't so high. And yeah, as we see, elongated here because that's obviously the spread of members at this time, and then obviously tries following the trough, and we can obviously see our steering influence a little bit better. We've got that ridging, subtropical ridging there, and it will go there following this weakness in the trough. This weakening in the high pressure that we got here, weakness in the ridging. It'll follow through, and it'll try to go after that upper trough that is that's passed nearby. It does so slowly because that influence gradually does decrease before another trough comes in and then picks it up. We'll go into another view to take a look at that a bit better. ECMWF, again, we can see here, westward solution. We can see this bridging does seem to be a bit more influential. And yeah, we can see that troughing there. It's there, it gets through, and it does have that more gradual turn. And that's only from what it looks like to be this trough passing by that allows it to actually. I feel like this turn is only weak because it initially loses control at our first trough, or it loses, I guess, touch with our first trough. It doesn't quite make it, but another one allows it to get picked up later on. That's why it's a bit of a slower evolution, I think. Fortunately, I can't take a look at exact timestamps on this plot, so I can't really compare in terms of timing. Can't really compare in terms of timing what's happening with regards to. Sorry, something's going on my tabs. Can't compare in timing relatively what the uncertainty is between the two ensemble models. But nonetheless, we can obviously visualize this a little bit. Actually, what I would do is, let's leave this real quick. Let's take a look at position relative at hour 60. So that'll be hour 54 on the GFS, or even better, we'll look at hour 66, and then we'll look at hour 60 on the GFS. Sorry. This fly keeps annoying me. It's actually really bad. Hour 60, okay. Yeah, we can evidently see a pretty big trend here, where the GFS is much faster. So this is the GFS. We've got it at, actually even better, just put those. We can look at it and observe the changes between them of latitude. We've got 29.9 degrees south here for the GFS. For the GFS, sorry. It's at hour 60. This would be hour 54 at the time of recording this, but not really that relevant here. We're going to take a look at why this is different, right? This is stronger trough influence. Again, I just wanted to evaluate this and do comparisons to make it clear. 29.9 degrees south, and the ECMWF is only at 28.2 degrees south. Big kind of difference there. Quite significant really between the two models, and just goes to show that we do need to observe timings of trough approach and trough influence to see how to make the best forecast. And with the GFS, one thing to also note is that it typically does actually get its trough interactions a little bit too fast as well. So, rule of thumb, if there's a situation like this, best to take the mean, best to take the difference between the two in terms of timing, and yeah, just go right in the middle really as a baseline really when you're making a forecast. Or obviously, it's very important to take a look at other factors as well. If there's any differences in the steering environment, in the synoptic environment, and then just to see if there's actually any notable differences, how they're playing out right now, and which solution appears to be more likely based off those conditions. But nonetheless, I feel like very similar kind of forecast environments here. I mean, let's take a look at GFS. Here, you know, that trough is there, a secondary trough comes. There's good certainty that we're going to get a setup that composes of a ridging here, first trough there, passing ridging there, second trough that moves there, and that second trough is what picks it up initially. But this first trough has the current influence there with this ridging also supporting. And that's pretty set in stone, except the timing, because of certain biases and certain kind of reactions to environments. Obviously, there is some differences. We're going to assume that timing will be a bit better when it comes combining the two guidance together and taking an average. Now, environment matters here. We've gone through the upper level environment and already and how it looked initially, but it's best to also take a look at the environment later on, because when you're forecasting intensity, you've got to know what the environment is like, and then you've got to evaluate what implications that could have on intensity. So, there is some sort of upper level anticyclonic flow just to the north of the system, which isn't too detrimental because it's not like we've got any northerly flow being impinged, any significant northerly flow. We've talked about how there was some northerly flow like coming in from there, kind of in this general area. That might be why we've got this little anticyclonic turning. It's minor though, it's nothing too big, but it is still there, something to note. Overall, this is the same anticyclonic environment here that is bringing some nice anticyclonic flow there, and also poleward to some extent. Though mainly that is only enhanced because we've got this flow venting into an upper low or upper trough, but it is an upper low. It's a closed upper low that cut off from the west at least recently, and we've got nice upper level divergence that is venting into the upper low. I'm going to draw that finally much better. There we go. That's good. And this is the same flow that I've been talking about. That will be impinging, and that already is impinging on the system. And that broad, nice up-level anticyclonic that Honda is going to be making much use of, that is going to be affecting the system of Garance a little bit. Now that system will be moving south. What the GFS suggests in terms of intensity here, as you can see with that rising pressure, is some weakening, minimal weakening, and it does not surprise me because that outflow environment really does get to it by hour 30. This is because the upper level anticyclone shifts here into the open Indian Ocean. It's just southeast of Madagascar, and that anticyclonic flow becomes more prominent over Garance, and therefore that shear really increases. And you can't really track it on it anymore because the vortex becomes so weak as it enters the subtropics. And you can see the same here for the ECMWF, and this is where I want to talk about initialization of pressure here. We actually talked about it in one of the previous videos. I think it was Bianca. We can take a look at 6 here. 980 only. So 980 is absolutely nowhere near the current pressure that we have. And we see 985 is the initialization pressure is 991. So that's even better, isn't it? It's not, but it's much worse compared to the GFS initialization, which at 18Z, if we go back to that run, it was 971. GFS does take in information from the JTWC best track, or whatever best track there is, right? And the ECMWF doesn't. That's why we've got a pressure difference initialization of 20 millibars. And trust me, GFS is much more accurate here, because it does take in the best track from the from whoever controls it, aka the JTWC in this case. And the ECMWF doesn't. That's why we've kind of got a bit of a bias between lesser influence, more so, and definitely not worth being able to take the ECMWF intensity value at face value. But one thing to note though is that going on from later today, or going from now to later today, look at that pressure go down. It's decreased to 962. So let's go back here. At 6E today begins at 980, and it goes down to 962 in a good decent 21 hours before making landfall. Now, because it actually seems on this model to be making more, first of all, there's less of an upper anticyclonic environment here, and that helps because flow is actually able to evacuate this way, which the GFS does not show. This enhanced upper level divergence could really help. I mean, we've also got this venting into the upper low that we have here as well. That's not different from the GFS, but one thing to note that's different from the GFS here on this model is that we have a very more stark intensification here. likely because there is actually some availability to evacuate outflow more equatorward, which the GFS doesn't have. And that's why GFS probably weakens it, is because that outflow environment that it has is not able to offset the environment that Hyundai is bringing it. And trust me, the ECMWF, also CA, it does have this as well. It does have still nice southerly flow impinging onto the system, so there probably there would be some concerns regarding around that, but nonetheless it's a little bit lower than what the GFS has. That outflow regime that it has on this run, Garance, is much better than the GFS. I mean, let's do some direct comparison here. Although it does have an outflow regime that is similar. Clearly that's not the case right now. This is Wednesday, sorry. Yeah, there's some up level outflow there. Absolutely, there is. I don't deny that. Actually tries to make the most out of outflow as it positions where it's positioned on the relative to the upper level higher. I can't draw. It does try and make the most out of whatever outflow it can get from the gear, venting westwards, and it does. It does certainly have some outflow, but it's not as much as the ECMWF. The ECMWF does suggest a better, more favourable outflow regime equatorward at this time before it makes an outflow in that reunion. There's some, I don't deny it. But one thing to note as well is that very quickly, actually I shouldn't even be looking at this run, it's a completely different run. I don't think it'll be much different though. I know it quite actually is, to be honest. Yeah, there's some venting into the upper level anticyclonic flow to the southeast, to the southwest, sorry. But it's much weaker, obviously. I was wondering why it wasn't much weaker, because I was just looking at this and it was much different from the ECMWF. We'll see what the 0Z ECMWF model run does show, because we were just looking at the 18Z, and the 0Z could certainly have changes. Obviously the GFS run is newer, so it could be taken in the environment it could be more realistic. We'll see what the 0Z ECMWF has when it comes out. I mean, I'll take a look and I'll figure out if what the ECMWF has is a consistent thing, and is it actually more likely to play out or not. Anyway, see here, GFS, it doesn't make most out of this upper level low completely. Outflow really becomes limited, it literally only goes there and nothing else. We've got very intense southerly flow impinging, so divergence cannot really occur to the greatest extent. And then yeah, let's compare to the ECMWF. It's got anticyclonic regime that's actually gone to the northeast of the system, so this is good. Obviously this allows for intensification because there is allowed to be divergence to some extent on this run. We got nice divergence that goes equatorward there. Both models agree on that, but because there is an upper level high there, a weak one, albeit, but still one, outflow is able to go out. Even though that upper low does go away, we still do have a nice outflow regime, and the upper level flow doesn't actually impinge on the system so much. But as I said, that's the 18Z run of the ECMWF, and we could see some changes in the next run. We'll have to take a look at that and make observations there. Now, special mention for HAFS and the HAFSN, the regional hurricane model that we have here. This is a new regional hurricane model. I mean, not that new, first observed in 2023 publicly, but we can make observations here, and I wanted to take a bit of time to see and give special mention to this model. Although I think we do have a newer run coming out. I mean, actually, let's reload it, and then yeah, let's take a look here. Has it loaded in fully? Yes, it has. Right, so let's take a look at the newer run of the HAFS model, and what do we see here? Well, initializers at 962, so that is ideal. That is, well, sorry, that wasn't even initialization. Is that 954? I have to read. I'm completely blind, so I mean I can't see it. Yeah, I can see. I can see here, why, yeah, 954. Okay, alright. Sure, it's, for Zero Z, I'm gonna have to look back at what it looked like at Zero Z. Let's take a look here. 954, yeah, not too far off. I think it might be a bit too low, but we'll go with it. Not a bad initialization compared to the eSIM-WF, which was probably about 20 millibars high. 20 millibars too high on its initialization, but yeah, let's ignore that. Just to note, Halves also takes in data from best tracks, so it'll be a much more reasonable evaluation at the initial intensity. And we can see here, it doesn't change much in intensity. If anything, it does actually plateau, maybe weaken some before it makes landfall in La Reunion. And yeah, it goes down here. And then it makes this extratropical transition, or at least it attempts to, before it finally completes it later down the line. But one thing to note though is that obviously I'll look at the GFS in a second, the eSIM-WF, because I actually haven't taken a look yet. Well, I should have, but the intensity actually stays pretty good, pretty solid for a good while after La Reunion. After La Reunion landfall, I'm not sure what the influence is from Hyundai. This could verify actually. I don't like the sudden. I don't really find it very realistic. The sudden weakening that happens over La Reunion. Even islands like La Reunion shouldn't weaken systems so detrimentally. Maybe if you pass on the western side, you might get some eyeball degradation. I mean that'll happen everywhere though. But yeah, it keeps it 970, 972, and then it gradually weakens slowly. The models literally rapidly weaken it over La Reunion. And it goes right down to 990s in terms of pressure. So yeah, that's the difference between key difference between the global and the regional hurricane models. But one thing to note in terms of steering and track, which is quite important here, makes a direct landfall in La Reunion within the same steering pattern. So now that we're taking a look at halves, I feel like the yeah, as I said, I think the landfall does appear more realistic. Obviously, I did mention that earlier. I thought that before looking at this anyway. Typically, near-term solutions GFS can get right in terms of steering. It's looking prominent anyway. If we look at radar, generally near-term, although a bit far from La Reunion at this time, we can probably evaluate that there is potential for it to go either way, but it looks to be heading towards La Reunion itself, and it might be making a more direct landfall. But definitely worth taking a look closely through time, and definitely taking a look over the next 24 hours to actually see the near-term, short-term evolutions to see if it will make a final, if it can make like a last-minute adjustment or something, because that's certainly possible. Eye wobbles can take off landfall. We'll have to observe what we have at the time. And yeah, obviously we've got halves here, and I wanted to take a look and compare the kind of, obviously we see that the pressure and the vortex load tracker like rapidly gets wiped off the map, and before that the pressure rapidly rises. Let's take a look at. We'll be able to look. Yeah, that's because really it actually becomes so tight of a vortex. I don't think it's like weakened like significantly. It might just like, but it does weaken. It does weaken right after passing that reunion. But it becomes such a tight vortex. It doesn't actually get tracked. At least the low indicator doesn't really appear. And same with GFS. I mean, if we take a look here, yeah, it weakens rapidly over that reunion. I don't think that's realistic in itself. I mean, looking at the isobar, like the gradient, isobar gradient that we got here, pressure gradient, it's not particularly steep. So that's definitely a weak vortex that GFS has there. The eSIM-WF actually surprisingly has a stronger vortex here relative to the GFS. It actually held on a bit better. But what do I expect? actually, I want to take a look at soundings, but initially my first thought would be, the weakening isn't realistic. I mean, I've just said that. Really, it's not realistic to me. Not many storms. I mean, first of all, we don't have many storms that passed over La Reunion, but those that have haven't weakened so quickly. I do know that we've got outflow shear coming in from Hyundai, but would it weaken that fast anyway? The storm I'm talking about, Grassy. Well, let's take a look at the soundings and actually take a look at closer detail what we have. So, this is way too far out. This is not where we should be looking. We know the environment gets worse here. That's typical natural. If we look into, as we got the outflow shear, and it just enters the subtropics, and typically the environment does get worse at this time. But main environment area that we need to focus on is just before landfall, or 0Z, 18Z, 27th. We'll take a look at. First initial sight, right? Because I want to look through the whole environment, so I want to start from this time at the moment, and we'll go all the way through until after La Reunion, because I want to look through every step closely. Obviously, I haven't looked into this in depth. I'm obviously doing this first time as well. When it comes to taking a look at the system itself and what we have here, I am a new viewer as well. So, 500 millibar flow here, 850. We've got motion vector steering at about 7 knots at this time, heading east south, southeast, and generally what we have is I want to take a look at here because it might be a bit more understandable. We've got southerly flow in the upper levels, weak and stark at 100, but that's almost not relevant. And then we have generally a nice easterly flow at 250. This is upper level, and then it turns a bit more northerly at the 300 to 500 millibar level, and that is why we have some that's coming from the weak minor ridge that we have coming from nearby to northeast. If we take a look here, we'll take a look at this first. Yeah, so it's this bridging environment that we got here that, again, it fails to provide that outflow for it, because obviously Honda immediately puts that southerly flow a bit further east, and therefore it gets trapped in it. But yeah, this same upper level anticyclone and probably deep layer ridge that we have here as well, you should note, will bring some northerly flow over it, as we've looked through the sounding here. And then, yeah, essentially some northerly westerly flow to some extent is impinging onto the system. That is extended from 500 to all the way down. I'll say. It's better to see on the holograph as well. I want to take a look at that, but I want to take a look at the wind barbs there first for a bit of a more just to slowly dive in, not straightforward. Get a bit of a straightforward understanding, and then yeah, we can see here, looking in, wind vector overall 500, 850. It is with a wind vector of 7 knots heading southeast, and all of it generally all right within the vicinity of of where it is on the holograph, the storm motion. Generally, what we've got with winds aloft is okay. It's not too bad here. It's not too detrimental. Obviously, we see the system handling it okay already. What do we have right now? A very good environment for sure, with max shear only at 10 knots, deep layer at 9 knots, and the max shear is only in the very far upper levels. This is a pretty good environment. Not too bad. But it does weaken. I'm not exactly sure where it weakens. Max shear only goes up to 12 knots. That's above 550. millibars. That's actually very good shear environment. Any outflow shear isn't really particularly too harsh even as well. Yeah, I'm not particularly sure, but we'll see. We'll observe. Um, Even relative humidity is not too bad, even though there is dry air on the flank here, being imported by that nearby upper level low that is down there. It shouldn't be too detrimental. There's no shear that will allow that really to happen. Any dry air importation into the core, I don't think that'll be happening. And then yeah, even this, I've already gone over this. This is not too bad. It goes near the motion vector of the storm on the holograph. It's not particularly too bad. Now it gets a little bit worse. We've got some low level shear that gets around there, but that's again, it's not too bad particularly. Nothing that will be too drastic, even though it's actually around 20 knots. Most importantly, we're looking at 850 to 500. Mid-level shear does kind of extend a bit too far southeast. Again, it goes up to 20 knots in the lowest levels, up to compared to the 10 knots steer vector that's being taken by the storm. This is where shear will start to kick in a little bit from the north, and that is not particularly great. And then, yeah, you also have, after La Reunion, you've got big collapse. That's a 30 millibar drop, 29 I think, after passing through La Reunion. Now, this is what makes me think this is topographic effects, where it is weakening through land interaction here. Surely that would have a part. It probably does in this one, probably a bit more than it should have. That's why I question the weakening rate. This level of shear, even though it's harsh in quite a few ways, it absolutely is. I don't think this will bring such detrimental weakening. It'll probably be weakening to weakening a mature system. We're probably looking at 15 knots per 6 hours. This is looking more like 25, maybe 30 even. That is a 30 millibar drop, very stark 30 millibar drop. And let's analyse the shear environment here, because a lot of the moisture is actually displaced to the north here. Why? Even though we got much of a northerly vector here, and yes, it's much stronger ambient wind vector that we got here, compared to the steering vector that we got here, or the vector of the storm motion. Although yes, it is stronger than that, and this is actually key. It will displace the mid-level vortex this way to the south, but most of our moisture content will go very far north. Very far north it will go. Very nice southerly flow will be kept quite a lot north. This is outflow shear from Hyundai, by the way, and it goes all the way to 25 knots, but generally sticks around 15 to 20. As you can see, moisture content stays that way. Although it does try to move closer to the vortex, it absolutely does. We can see there's attempts to fire there. Relative humidity values increasing a little bit near the vortex, near the low pressure center. Yeah, we can see it, definitely some shear, but there's also a lot of shear going that way. And yeah, we can see a bit of a better view in which direction they're going in. We've got some southerlies, some easterlies, and definitely a lot of northerlies going up to 500, 400. So, very complex, and this isn't a very favourable environment for sure, and certainly dying out here. You can see no organised moisture content near the centre there. That could be close to becoming a post-tropical cyclone, but we'll see how the convective evolution goes on at this time, because this isn't entirely representative. It gives us a bit of a rough idea. It definitely shows that it can't organise, because the ambient vector of the upper level of winds aloft, it's all over the place, and it will not be able to organise, or not be able to create a very nice stacked organised structure that we need for development of a tropical cyclone, or to at least maintain one. And yeah, after La Reunion, it goes all over the place. But it does take time for winds to die down. So this is why I still think it's a bit exaggerating. Although yes, that wind vector really does like massively. The wind vectors through height, it really do like drastically go all over the place very quickly. For that matter, I don't think this will be a cause for weakening of over 25 millibars in 6 hours. That's not really what I think will happen. Now that we've taken a look at this, now the halves that doesn't actually weaken it so quickly, weakens it a little bit more realistically in my view. Let's actually take a look at what environment that has to begin with. Now they don't have plots like these for the halves doesn't have plots like these or area average soundings that happen that are actually able to be selected, tracking the vortex extensively. But they have, you can definitely draw soundings of your own. Actually, it might just be some on the parent view. I don't know, but no, I don't think it is. Grazie. I was trying to look for it. I was completely blind. You got X sections, but you don't have. There was cross sections, but you can't have soundings on it directly plotted for you. But we can definitely take a look at a post La Reunion sounding. That might be a bit too. That's good. That's a good sounding box. Very similar environment to the GFS. That's certainly true. And we can see that shear in the deep layer is most certainly southerly. But we also need to note that that is because of this flow that's there, generally around 600 millibars to higher. But the majority of our mid-level shear and our low-level shear is mainly northerly. And again, we'll see we'll definitely see vortex decoupling to some extent. Wind vectors are all over the place as well. They're not aligned with the storm motion. So, yeah, again, very, very similar to GFS, except it's, again, you got max shear, 20 knots, but yeah, except the wind values in the upper levels are a bit lesser, but nonetheless still there. That's because the outflow shear doesn't extend over Garance too much. And yeah, we've got 10 knots, motion vector, 15, 20, 25, 850 flow, 25 knots. That's not particularly favourable. And that is northerly flow as well. So yeah. And then yeah, we'll extend further down, and we'll take a look. That evidently, this is where I don't need to draw. See very much disorganization. We see gradual weakening, but yeah, that the kind of profile that we got here, the wind structure that we got here, general inner core, low level inner core, we can see here, yeah, very lopsided. Evident that the vortex is weakening through height, and the vortex extension is becoming definitely a lot more decoupled. We can take a look here through height even. We've got 850 millibars here. 700 millibars. Let's take a look at this again. So we've got 850 there, 750 there. We can see, I think, that there is some displacement in the vortex already. I think it'll be better to take a look at vorticity. If we take a look there, so we got 850 there, and then we got 500. That's just a little bit further north. Yeah, that is an element of shear for sure, and it's a minor difference. It's nothing too big, but it's to note that there is shear. I thought this would be a bit more drastic. But I think what needs to be known is that there is going to be a lot of in a disalignment with the vortex. I think what's good to look at is if we take a look at a cross section and look at potential vorticity here. Hold on a minute. We look at potential vorticity here. Yeah, it's a very wonky. Obviously, as a mature hurricane still, it's going to be obviously okay. It's not going to be like a disorganized tropical storm at this rate. No, but not at the halves model run at the moment. Absolutely not. But it's definitely wonky. We can see here that the edge is like very wonky here, and it's take a look at the center of the profile. It's very. I'm not trying to make it wonky on purpose. I promise. If we look here and we look here, that way, yeah, it's wonky. It's not completely straightforward. There is shear impinging. We can shear impinging from there. Or should I say from, if we look at B, yeah, we've got shear impinging definitely from there, some shear from there. Yeah, it's all misaligned. It's not really too conducive for intensification. Therefore, we've got some weakening happening, and because the GFS actually gets it so weak, I feel like this would be much more evident in the GFS, and it'll be good to look at. So let's actually take a look. Let's give the GFS solution a bit of a cross section. What was that? It was 42. So although yes, it's a vortex, the low-level vortex is intact. Still, through the profile, through the column. Look at that. Very, very interesting. We can see here, if we follow the center of the profile, the center of the column of the system. Look through the profile, we can see there. It goes there, then it goes there, then the peak goes there, and then it's sitting very wonky. Sheer impact in there, we can see a lot of negative potential vorticity going into the system. There at around 600, 500 millibars, that is mid levels, and then we see quite a bit of impingement there. It's pushing there. This is in the upper levels. This is the upper level shear kicking in. See some shear impingement there. It's not particularly great. There's from all sorts of directions we see that there is a very misalignment in the vortex through height, and that is obviously as a result of the shear that we've seen on the soundings. Very complex environment ahead. Obviously, that is after landfall. Obviously, in a kind of environment like that, I still don't expect rapid weakening. Even the ECMWF, which is notorious for handling tropical cyclones, intensity specifically, not the best. It doesn't even weaken it too much after landfall. Where it does, but it actually holds on to that intensity quite well, and I think it even deepens a little bit after that. So it's interesting. We'll see how things actually play out. It's good to look at things in real time and see how it evolves compared to modeled expectations. It's certainly important to take a look at near-term evolutions, but also important to also learn how to take a look at model forecasts. Because I'm going to be completely honest, that is a complex solution that I am not very familiar with, but I can analyze to some extent. Let's take a look at the latest latest radar imagery. I've been doing this for way too long now. Let's take a look at the latest radar reflectivity again. What currently I have again. Bulk of our reflectivity is on the south side there, as of our latest scan at 710Z. Most of our reflectivity is there. We've seen that there is going to be some impingement of southerly flow, which will reduce any upshear wrapping. What I mean upshear is wrapping there. Obviously, that flow is going to be impinging this outflow shear, and we also got to know that there is going to be some shear increasing through the day, and going into tomorrow from the north, mainly our mid-level shear coming from there. Obviously, yeah, we are going to have some problems wrapping that reflectivity that way as well. And uh, that shear, although could try to suppress an eyeball replacement cycle attempt, it certainly could build a secondary eyeball formation. Could potentially start. We see a lot of banding already building on this side, on the inner outer periphery. I know it doesn't sound right, but yeah, really, we've got quite a bit of banding forming there, and there's some here as well. But we'll have to also see if it consolidates fully on this side and this flank, where shear will be most detrimental. Again, we've got to keep looking and keep seeing what happens. I'll make a video tomorrow morning evaluating the landfall of La Reunion, in La Reunion as it happens, with Garance going through. And then I'll probably talk a little bit as well about how it's evolved in the 24 hours prior to that, after this, which will happen after this video, and see how well my analysis is verified, and we'll see what has actually changed compared to what I've actually looked through and analysed. Because yeah, it's definitely good to see what my own analysis has gone, if you know how accurate it is, how it's gone through as well myself. It's a learning experience for everyone. Again, I'm no professional meteorologist by any means, and I'm also not the official source. So take a look at Mateo France and what they've issued for their products, because it will be most accurate from them, and their analysis will be most useful. Best to take a look through. Now, because it is 722Z, I think we got a new advisory issued, or new cone products issued, and we certainly do. They have now upgraded Garance to a intense tropical cyclone intensity as of this advisory, and they forecast it to last for 12 up to 24 hours up until landfall, where they expect weakening to tropical cyclone status before it ends up keeping its intensity until the until 1st of March. This is kind of what I expect. The ECMWF and GFS solutions. I think ECMWF might be taking it to a category 1 there. Again, I can't take a look at the minimum pressure solutions. I mean, one thing that might be useful is to take a look at soundings, and then we'll be able to take a look actually. But again, it's nothing too specific that we should be looking into, because I can't take a look. Okay, well, that's great. Nonetheless, ECMWF probably takes it to a category 1, but what I'm trying to say is that even the global model solutions, even though they vary, whatever, one might be a bit stronger than the other, they both take it very low, low in intensity, high in pressure, high in minimum central pressure, and the half solution looks much more realistic. I know the environment is actually a bit whack. It's a bit horrible. The shear vectors and everything and the soundings don't look particularly great, but even in that environment, I don't expect 25 millibars weakening, and it will probably maintain tropical cyclone status like Mateo France forecasts. I agree with the halves. It looks like a much more genuine, much more realistic solution, so I would believe a little bit more in that. But overall, what would I think overall, taking into account all the available information that we have? A direct La Reunion landfall is possible. A slight westward shift, I mean, sure, it's possible. La Reunion, Mateo France, they expected themselves a little bit more compared to their last forecast, actually. But yeah, still a direct landfall, a landfall that actually happens, could happen. Again, what's most important is best to keep an eye out for eye wobbles or any other near-term evolutions to see if it does actually pass through or nearby. And most importantly, yeah, see what happens after that reunion. It could weaken quickly. It could weaken quite a bit, but again, as I said, probably not to the extent that I look at. The halves model looks realistic, responding to the environment, and going through that reunion, maintaining tropical cyclone status is likely. And in terms of near-term peak intensity, I think it might have reached its peak intensity already. The environment only gets progressively worse. It could probably strengthen just a little bit further in the next 6 hours. I mean, let's take a look at the latest imagery that we have here. You know, it is trying to wrap, it certainly is, but our central dense overcast, it's getting a bit thin on that side. I know it's wrapping, but and I know it's also still in the process of stabilising. But it's trying, but it's a very thin central dense overcast. I don't think it's going to last very long. Yeah, I'm not particularly sure. We'll see how it evolves. I think it still has 6 hours of strengthening a little bit, but it might be nearing its peak intensity now. What would I estimate it at right now? Probably about 105 knots. I agree with the analysis by the JTWC. It could probably get to a brief Category 4 peak intensity, but that's probably the highest I would go and expect. Some weakening before La Reunion, certainly possible. I don't see anything else really happening. I don't see any extreme weakening before, nor do I expect any extreme weakening after, really, to such a large extent. Though some gradual weakening is certainly something that I would expect, given the environment from outflow shear, coming from Hyundai, and northerly mid-level impinging onto the system as well. So, thank you guys for watching. Thank you guys for taking the information. Sorry, it's been a bit long. If you've sped up the video, then you're a genius and absolutely should be doing that, because I waffle too much. But if you guys find these videos insightful, make sure to leave a like and subscribe. Hope you guys enjoyed. That is me talking about Garance. Follow the latest information. And yeah, keep updated to the latest information. And also, if you want to learn more, keep updated to me. And again, subscribe. Put notifications on, and yeah, you'll be able to watch more of my videos. So thank you for watching. I hope I have you guys watching my next video. Thanks for watching, guys.